This assessment tells us that the ester shown below does not participate in the Claisen reaction. Now, if we look at that ester, it has an alpha hydrogen and it's an ester, so why not? Well, let's think about how that reaction occurs. Well, the first step, and we're not going to go too much into the mechanism, but we will show at least what's happening in each step. The first step is going to be to form the enolate, right? If we want to do a Claisen, we need to be able to make the enolate, and we can make the enolate. Now, we should point out that this deprotonation with sodium methoxide is going to be favored in the direction of the neutral ester. So the first step is unfavorable. The next step would be that this would react with another molecule of the ester. And again, we won't show the whole mechanism, but the nucleophile will attack, push the electron pair up, collapse back down, kick out the good leaving group, so that we would end up initially with this product. Usually you end up with a beta keto ester as the product of the Claisen. Now, we would probably want to number our carbons to make sure we have this right. So 1, 2, 3, 4. We'll call this 5, 6, 7, 8. We're making a new bond between 2 and 5. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. The numbering works out. So this could conceivably be the Claisen product because it is a beta keto ester. But this reaction here is also favored to the left. It's not a particularly favorable reaction. So we have an unfavorable deprotonation and a slightly unfavorable next step. Remember with the Claisen, the driving force is that once we made this, we removed another alpha proton to make a stabilized enolate. What do you notice at this carbon? There are no alpha hydrogens. So the step that's going to be favorable, the step that's going to be the driving force for the Claisen can't happen here because the ester we started with only had one alpha hydrogen. For that reason, this ester will not do the Claisen reaction.